We talked when we were discussing the behavior of waves, what happens when a wave actually encounters a boundary between two media. So for example, if you have a light wave that is going through the air and it suddenly hits glass or it suddenly hits water, what happens to that light wave? And normally what's going to happen is for most media, part of the light wave is going to bounce off of it and part of the light wave is going to go through the media. Again, it depends on what media exactly we're talking about, but a lot of times light waves will partially reflect and they will partially enter the medium. So what we're going to specifically be talking about in this lesson is what happens when a wave reflects off of a medium. We looked at it very briefly when we were talking about waves before, but we're really going to get down into more of the nitty-gritty because it's a little bit easier to see when we're talking about light because we can think about mirrors. So here I have this line is going to represent a mirror. So let's say that I have a light wave coming in at this angle, okay? Now, if I, right at the point where this hits, if I draw another line that's perpendicular, meaning it's at right angles, it makes a square corner with the mirror. This line is called the normal. I don't know why it's called that, but it's called the normal. And so this ray, because it is the one that comes in and hits the mirror, this ray is called the incident ray. Okay? And it makes a very specific angle between the normal and the incident ray. When that ray bounces off, what happens is that it's going to bounce off about like this. And when it bounces off, this is called the reflected ray. And this ray also makes an angle with the normal. This is called the angle of incidence, and this is called the angle of reflection. And what's always true, and I'm not sure you can tell exactly from my drawing here, but the angle of incidence, and if I were going to write that with symbols, I would do it like this. The angle of incidence is always going to be equal to the angle of reflection. So the angle of incidence equals the angle of reflection. Now, if you've ever enjoyed playing pool, or even if you just throw a ball against a wall or you kick a ball into a wall. I know sometimes one of my daughters goes downstairs, if all of her siblings happen to be gone, she will go downstairs and she'll kick a ball into the wall because then it'll bounce right back to her. Well, if you kick a ball into a wall or if you throw a ball into a wall, you also would recognize this particular kind of behavior because whatever angle it hits with is the same angle that it's going to come off with. If you're standing straight onto a wall and you throw the ball straight, it's going to bounce straight back at you. If you're more at an angle and you throw it this direction, then it's going to bounce off this way. And so you can think about that in terms of pool. You can think about it with balls on walls. You can think about it in terms of light rays hitting mirrors as well. It's all the same type of behavior. That's all reflection, and these angles are always equal to each other. Okay, and also notice that this angle is measured with the perpendicular to the surface that it's hitting. I could measure these because this angle would be equal to this angle, but this one is classified as the angle of incidence, and this one's classified as the angle of reflection. Okay, so basically this is what the law of reflection is. The law of reflection says that if you have a ray bounce off of a surface, the angle of incidence is going to be equal to the angle of reflection. So this is the law of reflection. Now, because that's true, we could actually look at ourselves in a mirror. This is you. And let's say that I have a mirror that's only about that long. can you see your whole self in that mirror? Can you see from head to toe all the way? Well, actually you can, because what happens is that the light rays that are bouncing off of your foot can then bounce into your eye. And so here you can see that the angle of incidence and the angle of reflection are going to be equal to each other. So in order to be able to see yourself, see all of yourself in a mirror, that mirror only has to be half as long as you are tall. Now, the interesting thing about your brain is what your brain does is it assumes that the light rays are coming off straight. So what it does is it sees your image, well, and it would actually see you as the same height, because I'm not drawing very well here. Okay, it would see you as the same height, and it looks to your brain that you are as far in front of the mirror as your reflection is behind the mirror. And your brain says, well, if I'm seeing my feet, it must be because my feet are straight back from where they actually are. They're not in this image that you see, but that's what your brain puts together and believes. And that's why when you back up, it looks like your reflection backs up as well. Or if you get really, really close to the mirror, it looks like your reflection gets really, really close to the mirror as well, because your brain is going to put that construction into what it's perceiving, and it's going to assume that the light rays are bouncing straight off, and so therefore the reflection that you see is as far behind the mirror as you are in front of the mirror. Now, the law of reflection is always true no matter what kind of surface that you have. When we're talking about a nice smooth surface like a mirror, all of the light rays, so if I had several light rays that all came in from the same direction, like if you had a flashlight shining in this way, or if the sun was shining in this way, all of these light rays would be reflected off. They would all be reflected off parallel to one another because they all came in parallel. But if you have a really, really rough surface, so maybe it's just, maybe you're shining on the ground out there, and this would be, blown up. So if your light rays are coming in like this, maybe they're all coming in parallel because the sun is shining on it, but they're not all going to bounce off the same. So this one's going to bounce off like this, but this one is going to bounce off like this, and this one's going to bounce off maybe up here, and this one's coming in here, but it's going to bounce off over here based on the particular angle that it comes in at to wherever it hits. The angle of incidence is always equal to the angle of reflection no matter where it hits, but if those light rays don't bounce off in the same direction, you can't see your image like you can if the image is, or if the surface that it bounces off of is nice and smooth. So if you have a situation like this, your book defines this as a diffuse reflection, where everything is bouncing off in all sorts of crazy directions. And this one, where everything is bouncing off of a smooth surface, it's calling this one a specular reflection, because it's nice and smooth and you can actually see your image in it when it does that. Now, some of the uses that we have found for mirrors also involve curving that mirror's surface, because when you curve a mirror surface, it's going to vary the type of image that you see in it. And if you go on to take physics later on when you're in high school, we're going to go into a whole lot of detail as to how these images are formed and the different kinds of images that are formed. But for right now, I just want to look at two different types of mirrors and the way that they're used. So the first example I want to look at, give us a little bit more space here, is if you're standing here and the mirror that you're looking in is curved this direction, okay? That is called a concave mirror. And if you look at it, it's kind of like the mirror has been kind of caved in. That's how I remember the difference between these two. A concave mirror is used if you want to magnify an image, if you want to make it look bigger, or if you really want to focus focus all of the light rays in one particular place. So if it's used in magnification, if your mom has a makeup mirror that she uses to put makeup on, a lot of times that makeup mirror has a magnification to it, and so it's actually a concave mirror. It's going to make her image look bigger than it really is. It's also used to really focus light rays, so you're going to find it in things like flashlights. You're going to find it in things like headlights, because what happens is that if you have this shape, then they're going to take the light bulb and they're going to put it right here, and so all of the light that goes back here is going to be reflected out this direction, and it's going to really make a pinpoint sharp light beam out this way, which if you've ever used a flashlight, I'm sure you've used a flashlight, you're going to notice that it makes a very sharp pointed beam, and it's because of the concave mirror that is back behind that bulb. The other type of mirror that we commonly use actually bends the other way, and it's called a convex mirror. And convex mirrors are used if you really need to get a wide angle view of something. So a lot of times a convex mirror, you're going to see it used in security systems. You're going to see it used on side rear view mirrors on your cars. And you'll notice a lot of times those mirrors have messages written on the bottom of them that say, object is actually closer than it appears, because a convex mirror is going to fool you into thinking the object is a lot closer, is not as close as it actually is to you. So you have to be careful when you're using those mirrors to judge your distance properly. You're also going to see these in a place, like if you're trying to see around a blind corner. They're especially common in hospitals, where if there's a corner coming up, and especially, you got people, doctors and nurses pushing patients in beds, these great big huge beds, and you don't want to run into that. They don't want to run into anything, and so they put a convex mirror up at the intersection of some of these hallways, because then they can see what's coming down either hallway, so they make sure that they don't hit anything. So these are some of the uses of a convex mirror, and so they have very different uses, but both of them are all based on the law of reflection.